Okay, suppose that the population mean test score is 100, mu equals 100 with a standard deviation of 10, or sigma 10, and suppose that my sample size is 100. What is the shape of the distribution of sample means? Okay, let's see. Okay. Because the sample size is 100, which is way more than the magic number 30, so it's going to be normal. What is the expected value of the distribution of sample means? Expected value of the distribution, expected value of the sample means is going to be the same as the population mean, which is 100. So it's going to be 100. What's the standard deviation of distribution of sample mean? Okay, in other words, standard error. Okay. What is it's going to be okay, this formula. Okay, standard deviation of sample mean is going to be a population standard deviation divided by the square root of sample population. So in this case, okay, standard deviation is 10, and the population is 100, so it's gonna be 1. So standard deviation of the sample mean is going to be 1, or standard error is 1. That's okay. Okay, next question, next problem. Suppose that in the population, height normally distributed with a mean of 66 inches and standard deviation 2 inches. Suppose my sample size is 25. What's the shape of the distribution of sample means? Okay. See, it's normally distributed. Population is normally distributed. That's why it's gonna be normal. What's the mean of the distribution of sample mean? It's going to be the same as the population mean, which is 66. What's the typical amount of sampling error for sample mean in this scenario? Okay, so in other words, it's a standard deviation of the sample. Okay, which is standard deviation of samples or standard error. Standard deviation of samples, sample means, standard deviation among the means of the samples, which is a standard error. So how do you do that? There's a formula again. I don't really have to write it, but that's it. Okay, so standard deviation means is okay, in this scenario, my sample size is 25. Okay, standard deviation is 2. Population standard deviation is 2, and the sample size is what is for the 25? In other words, yeah, 0.4. Okay, that's what it is. Okay, problem number 3. Suppose I repeat the question 2 using the sample size of 100. What's the shape of the distribution of sample means? Okay, for 2 reasons it's normal. Okay, because previous example, the population mean was normally distributed, so of course it's normal. At the same time, even if it's not normal, because sample size is 100, it's gonna be normal. So for 2 reasons, it's gonna be normal. Alright? Normal. What's the mean of distribution of sample mean? It's gonna be the same anyway, so it's 66 again. What's the typical amount of sampling error for sample mean in this scenario? It's gonna be different because the sample size is different. Error is gonna be smaller this time because sample size is bigger. Let's calculate that. So and this is standard deviation of 2, right? And divided by this equals, okay, is the standard error of the mean larger or smaller than it was in question 2? It's definitely smaller. As I said, sample size is going to be larger. It's larger this time, so error is going to be smaller. And from the number here, this is the 0.2, and it's definitely smaller than 0.4, so it's smaller.